So today we're going to start talking about regression. So let me get a pen tool up here. Okay, so what is regression? Well, its main use. Well, it's to draw conclusions about the relationship between two or more variables. So use the chi-square to see if two variables were related, and then afterwards we could if we did conclude they were related, we could say what the relationship appeared to be. But now with regression, we can have more than two variables. You can actually put more than two variables in a chi-square test. It just gets very messy, and it's very hard to get any relationship out because chi-square looks for anything, so it's not very powerful. While in regression, you can get more of a particular relationship, especially if you kind of have an idea what the relationship should be. Then you can kind of test that particular relationship. Assumptions, again, the only assumption we're assuming here is we've got a random sample. Actually, it's not quite that strong. We assume that each observation is independent of one another, but random sample covers that. And we're going to start off with simple. The simplest type of regression is called simple linear regression. As it says here, you can have, in simple linear regression, you have two variables. You have a y, which is the response, or dependent variable, either name is fine. X is the predictor, or it's called the explanatory or the independent variable. So those are your two variables, y and x. Later on, we'll see you can get more than one x, but that's no longer simple regression. And it's linear because you're fitting a straight line. So simple because you've only got two variables. Linear, you're going to fit a straight line. And we'll see later on you don't have to fit straight lines. You can fit curves, whatever you want in regression. So our main equation is y equals a plus bx. That's a straight line, right? So that's the form we're talking about here with simple linear regression, just a straight line. So let's go ahead and just dive right into it. Sort of the easiest way to understand what's going on is just sort of get into it. So what we have below here, and I'll scroll down to it, is a simple example using some data that we used a lot actually in the first half of the course. We're going to look at the states data. So we're going to look at an example using the states data, so the states.mtw here. So let's go ahead and Minitab. I'll bring Minitab in here so we can see the states data. So here we have the states data in Minitab. Remember the states data, the first column was the postal code for the state, and actually here we had 51 because we had all the states plus DC, right, District of Columbia, which is in the state. So actually it's states plus DC. Then they're broken into regions of the country. So East, South, Central, Pacific, Mountain, West, South, Central, and so on. Pacific, South Atlantic were here. Population. This is some old data, but it was still useful. This is population from the census back in 1990 in thousands. So Alabama had about 4 million at the time. Alaska had about 500,000, a little over 500,000 at the time. Arizona only had less than 4 million at the time, which now it's much bigger because they're retirees. We also had the verbal and math score, the average verbal and math scores for the whole state for the seniors in high school who took the SAT in 1990. So in Alabama, the average verbal score was about 470 for the seniors, and the math score was 514. And we also had percent of seniors who took the test in that state in 1990. So only 8% took the SAT of the seniors, took the SAT in 1990, while in Alaska, 42% took it. We also had some other variables, dollars, which was average dollars spent per student in 1990 in the school system. So that was all the dollars spent in the state on the school system divided by the total number of students in the public school system. And pay was average teachers' pay in thousands. So in Alabama in 1990, the average teacher, a public school teacher, got about 27,000, while in Alaska they got a lot more, 43,000, because who wants to live in Alaska, right? So they got some extra money to go there. So those are sort of the main variables. So the two we're going to look at are SAT verbal the average verbal score for the state. Okay, so that's going to be our y, our response, and percent, the percent who took the test, that's going to be our x, our predictor. And we're going to let Minitab fit the best line, do the best simple linear regression here. So what we're going to do is we're going to reproduce this plot here in Minitab, and here it tells you how to do it in Minitab. These are the steps in Minitab to kind of do this simple linear regression and get this plot. So it says go to stat, then regression, then fitted line plot. And we're going to reproduce the same plot as we have up here. So let's get back to Minitab. So it says, actually probably get them on here at the same time. Let's see there. Oop, don't get big on me. There we go. So we go to stat, then regression, then we go to fitted line plot. And now I did this earlier, so I'll take it out because I cheated to make sure things are working. So in verbal, verbal is going to be our response, our y. So you put the y, or the y becomes st verbal or C4, and we said we wanted percent or C6 as our x. And now we're just doing a straight line, so that's the basic option here. Notice later on we can actually fit curves, but right now we're doing linear, fitting a straight line. Just click OK, gives our basic options. There's the graph. Bigger version, but same graph. So notice what this graph gives us. We'll look at this big version right now. Here is the equation. That's the best fit line. So y equal a plus bx. That's the line here. SD verbal is 485.4 minus 1.15 times percent. That's our y equals a plus bx. This stuff over here, which is actually telling us how well the line fits the data, we'll talk about that in the next video. We're not going to worry about that right now. But that's kind of telling us how well the data fits the line. So here is our plot of the data. So all we have here is really just a scatter plot. So here's the plot of the data. The verbal is the y, percent is the x, and the data is here. And now we're just fitting the best line. And actually we saw this best fit line earlier. So that's that line up here, this verbal equal 405.4 times percent. That's what this is. That's the line. We saw this line earlier. That was just the best fit line when we did correlation. Remember when we played with correlation, the line moved around? That's the same as this regression line, this simple linear regression line. Okay, it's the best fit line to the data. Okay, so let's go back to the handout. Okay, so here's the same plot, just a smaller version. And here's our equation. Here's our y equal, equal a plus bx, right? This is the line here. So verbal's our y, percent's our x. So what does this mean? Well, actually the b is easy to interpret, at least in a straight line. The b here, equals, there we go, it's just a slope. So slope has nice interpretation, right? Slope is, all it is change in your y divided by your change in x. Right, that's all slope's looking at. So here it's telling us what? It's telling us, well, for example, for this particular data, so for example, this particular data, it says, I guess I should say here before I do that, we'll say here, make sure we say on average. So we're talking about in general what happens, right? On average or in general. On average. If percent, this is the percent taking the test, right? So if percent taking the SAT increases by 1 or 1%, then what happens to the average verbal score, the ST verbal score? Well, notice here our B is negative, right? It's negative 1.105. So it tells us then, in this case, the SAT, SAT verbal, the average SAT verbal score for the state what does it do? Well, it's negative, so it goes down. So it goes down. Let's change that down. I don't like that down. That's pretty ugly. There we go. Try to get a better down here. It goes down because it's negative, right? So it goes down because it's negative by 1.105 points. That's what it's telling us here. For every one change in percent, verbal changes by a negative 1.105. I'm not saying that everything does that, but that's on average, right? On average, what happens? That's what we're talking here on average. The line's looking at the average, what's happening on average. Okay, so that has a nice interpretation. It's the change in y over change in x. If x changes this much, y on average changes this much. If it's positive, y is going up, the verbal will be going up, but here it's negative, so the verbal is going down. So that has a nice interpretation. The other part, make sure I can get there, we go, still got the equation there. The a value, right? We've got the a value. Well, what is a in general for our equation here? Well, a is known as what? The y-intercept. Right, it's what if x is 0, then that's what y equals. That's what the y-intercept means, right? If x is 0, that's what y means. So this is the goes down here. So a really only makes sense by itself as a value if x equals 0 makes sense. Well, for example, what does x equals 0 mean? X equals 0 would be 0% taking the test. Right, 0% taking the SAT. So y equals a, the SAT verbal score, the average SAT verbal score equaling, in this case, 485.4. In this case, get a little more room, makes no sense. How can you have let's put have in there. How can you have an average score of 485.4 if no one takes a test? Makes no sense, right? So here, the 495.4 by itself makes no sense. You don't get there's no score. If no one's taking the test, there is no score. I mean, it's important to the model itself because it tells where the line goes, but by itself it means nothing. It's only in the terms with the B that it makes sense. That it kind of the A value, if we go back to the graph, the A value places where that line goes, right? How high or low it is. That's what it's placing. But actually saying what it means really nothing here by itself, because nothing. If you look here, if you look at this model here, I guess I'll use the green here. Notice here, see how well I can draw a line here. Not too bad. Come on, let me draw a line. It's not letting me draw lines. Come on. Let me draw a line. It's not letting me drawing it. But if you notice, maybe I'll do parentheses, then maybe I'll do a parenthesis. No. I guess because the picture doesn't let me draw on it. But notice it's not starting at 0, right? Here. It's not starting at 0. And it doesn't end at 100%. So one thing you have to note here about the model too, I guess I'll say it now, is the percents, the x's in other words, go from, actually we can find exactly what they go from. If I go to Minitab, I can do basic stat display for percent, and they go from 4% minimum to max of 74%. So here they go from 4% to 74%. So the regression equation or model is only really good in that range. So in other words, what I'm saying here, if we go back to the plot, actually I've got it down here below, we're going to use something else down here below. I don't know if this line really holds outside of this 4, it goes from 4% down here to 74% up here. I don't know if that line still holds. Maybe this suddenly dips down, maybe it suddenly goes up, same thing down here, I don't know. So outside that range, I don't know if it makes sense. So 0, obviously, x equals 0 makes no sense because it's outside the range of x values. We don't know what's happening out there. So that's what I mean by that. About the percents, the x's go from 4 to 74%. So really the model is only really good in that range. I don't know if it's changing outside that range. Okay, so that's the basic stuff of regression. The last thing we look at this particular video is what's your x and what's your y, right? How do you choose the x? How do you choose the y? There's kind of 2 ways you can do that. The first is cause and effect. That's the first one here. So cause and effect. So cause and effect relationship. What do you mean by that? Well, a cause and effect relationship says if you change the value of one variable, the other variable's value has to change. So if you change the value of one variable, the value of the other variable, has to change. Not that it usually changes, it has to change. That's what I mean by cause and effect. It has to change. Okay, so some things have cause and effect, some things don't. If you believe you have cause and effect, so if you believe you have a cause and effect relationship, then the X should be the cause and Y, so then X should be the cause, so equals here, X equals cause and Y should be the effect. So here, if we believe we have cause and effect, which I'm not saying we do, we're saying the percent, that's our cause, verbal scores the effect. So in other words, saying if we, since here's a negative relationship, it's going down, the slope's negative, it's saying if we decrease the percent who take the test, the score should go up. I don't think that's really going to be a cause and effect relationship. I don't think that's going to happen. I don't think by forcing the percent who take the test to go down, the scores go up, unless you're choosing who's taking, who's not taking, all right? Just happening by itself isn't a cause and effect relationship. An example of cause and effect, we do have cause and effect, would be the cause would be fat content, and the effect would be calories. And say here, an individual is a hot dog, not a person. So the individual is a hot dog. Because if we add more fat to the hot dog, we pump some fat in there, sounds yummy, then its calories have to increase. And we know exactly how much if you know how many calories and fat. Let's go ahead and get that increase it better. Have to increase. Keeping everything else constant, not changing anything else. Because fat has calories, right? If you increase the sodium, that's not cause and effect. Sodium won't necessarily cause calories to increase because sodium has no calories, but fat has calories. So fat and calories have a cause and effect relationship. Fat, since fat is part of calories, if you increase the fat, the calories have to go up. It's not the other way around, right? If you increase the calories, doesn't mean the fat has to go up. It could be the protein goes up or the carbohydrates go up, right? Doesn't have to be the fat. But fat has calories, so if you increase the fat, if you don't change anything else, the calories has to go up. That's a cause and effect relationship. So if you think you have a cause and effect relationship, make the X the cause, make the Y the effect. The other thing that's similar but a little bit different than cause and effect is time ordering. So time ordering. Okay, so example. I don't like that. Let's change that. Example. Oop, not sure it there. Oop, I guess it's okay. This is a little weird thing again. I'll get it here. Here we go. Example. Suppose in a class. So suppose here we have a let's make it a math class or something. You have a math class. In a math class, you have test number 1, you have test number 2, and you have test, and let's say the third test, the final. Well, in this case, you have time ordering. Things happen in time, right, in order. You have time ordering. The final happens last, right, in time. So the final should be y. The thing that happens last, the last to happen, is your y. Test number 1 and /or test number 2, because you can have both. We'll later on see how to add more than one x. Could be x's. We could have one x or we could have more than one x. Because the things that happened earlier are your x's. Because this makes sense. It goes on with cause and effect. The reason is, if you just think about it, the things that happen earlier in time, test 1 and test 2, they could affect how well you do on the final. Actually here, how you do on test 1 could affect how well you do on test 2. And how you do on test 2 on test 1 could affect how well you do on the final. But the final can't go back in time and affect test 1 and test 2. They've already happened, right? So that's all the idea here. Let's make that a little better. If you have time ordering, the last thing happen in time will be your y. Things happen earlier are your x's. Because you might have a cause and effect. And if there is cause and effect, then the things happen earlier, your x's, can affect the thing that happens last, your y. So that's kind of, if you're doing regression, kind of how to figure out what's your x, what's your y. If you have time ordering, the thing happens last in time should be your y. Because if there is cause and effect, that's the way it goes. Or if you think you have cause and effect, then again, y is going to be the effect, the cause, or cause is going to be x's. If you don't think you have either of those, then it's kind of up to you what you decide your y to be. But these are sort of the main things to kind of help you kind of choose how to choose y if you're doing a regression yourself. Okay, so we'll go ahead and stop here, and next time we'll look at those measures I mentioned earlier. If I scroll back up to this picture, it's these measures here which kind of tell you how well the data fit this line.